In many probability problems, it is necessary to find the total number of outcomes. This can be a daunting task if there are hundreds, thousands, or, like state lotteries, even millions of possible outcomes. So this section introduces techniques for finding such numbers. The first technique we're going to look at is the fundamental counting rule. For a sequence of two events in which the first can occur in m different ways and the second can occur in n different ways, the events together can occur in a total of m times n ways. And this rule will extend to situations involving more than two events. It could be 3, 4, 5 events or more. So there are 4 blood types, AB, and O. Blood can also be Rh positive and Rh negative. Finally, a blood donor can be classified as either male or female. How many different ways can a donor have his or her blood labeled? So when you're looking at these types of problems and there's a couple of different events or different ways to classify things, look at how many ways for the first classification, and there's 4 blood types. And then for the second, you're either positive or negative, so that's 2. And then you have a classification of being either male or female, and that's 2 options as well. And the fundamental counting principle says that we can multiply those together. 4 times 2 is 8, times 2 is 16 different ways to classify a blood donor. Next semester, you're planning to take 3 courses, Math, English, and Humanities. There are 8 sections of Math, 5 of English, and 4 Humanities that you find suitable. Assuming no scheduling conflicts, how many different 3-course schedules are possible? So, we have Math, English, and Humanities. There's 8, 5, and 4. Multiplying those together using the fundamental counting principle, we get 160 different possible schedules. Now, you're taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices, with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, in how many ways can you answer the question? Now, if you're thinking 10 times 4 for this question, don't. Your 10 questions with 4 choices, those are not the events that we're looking at. Each individual question and how you answer it is an event. So if we have 10 questions, we have 10 different events. And for each event, we have 4 possible choices. So we're multiplying 4 by itself 10 times. And another way to write 4 multiplied by itself 10 times is 4 to the 10th. So using our calculator, we find that 4 to the 10th is 1,048,576. On the last example, a Little League baseball team has 9 players. Find the number of ways the coach can arrange the batting order. So we have to think a little bit more on this one as well. If we have used one of the team members in our first place for batting, would they bat in the second or third place as well? The answer to that is no. So we have 9 players. Each one batting is an event. How many choices do we have for our first person up to bat? And that is 9. We have 9 choices. But whoever bats in that spot will not be batting in the second spot. So then we only have 8 choices. And the first 2 batters can't bat in the third, so we have 7, and so on, with it decreasing by 1 each time. So when we multiply these together, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, we get 362,880. Now, that is a lot of multiplying 9 all the way down to 1. What if it was 50? Would you want to multiply 50 times 49 times 48? No. There is a shortcut for that on the calculator, and we will discuss that shortcut and how to work that on the calculator in our next two topics.